3.02 similarity. Our objective today, students will identify pairs of congruent angle, corresponding sides, and similar figures. Students will write similarity statements. Here's the agenda. We have a couple models. Actually, there's 3 models in this. I just realized that's wrong. Our assignment here and 1 skills check. So we have a lot of, oops, that's too far down. Here's the next one. So we got a lot of notes here. So I recommend that you pause this video and copy this stuff down if I read it too fast for you. We have a line. A line, you probably know what that already is. It's a series of points that extends in 2 opposite directions without end. Here is a couple points on this line, A, B. And you can write it multiple ways. So you can write line A to B, which is this way, or line B, A. Or oftentimes will be a letter at the end of it, and it'll be a lowercase letter. And that'll also represent that line. A segment. A segment is a portion of that line between 2 points. So segment AB. A ray is like a segment and a line combined, essentially. We have a starting point, and then it goes on forever in one direction. And you'll see the arrow. That's the direction that it goes. So it'll be ray B, A. Angles. You probably know what these are as well. This is all review, at least it should be. Formed by 2 rays or segments with a shared endpoint called a vertex. So this is the shared endpoint, the vertex, and that's what forms the actual angle. Name of the vertex only, a number only, or a point from each ray segment with the vertex in the middle. So you can write it, this could be like angle T, R, A, or it could be angle A, R, T, or simply angle R. Congruent angles, angles with the same measure or equal. Congruent and equal are more or less the same thing. Angle pairs, okay, so this is where we're going to learn some more things about different types of angles. So vertical angles. Vertical angles are angles that are on opposite sides of rays. So right here, vertical angles in this scenario is 1 and 2. Those are vertical angles. Those are also congruent. 1 and 2 are the same angle measure. They are equal in number. And 3 and 4 are also equal or congruent. And all 4 of these angles will add to 360 degrees in this scenario. Or actually, whenever they cross like this, they'll always add to 360. Complementary is when we have 2 angle measures that add up to 90 degrees. So angle 1 and angle 2, if you add these up, they are complementary. That's what this right angle says. And one angle plus the other will equal 90 degrees. So 50 plus 40 is 90. And supplementary is just like complementary, except they add up to 180 degrees. So 3 and 4 would add up to 180 degrees. Here's our first model. So model A, the 2 shapes are similar. Name all pairs of corresponding sides and angles. Let me get my text tool. Move that right there. So angle LM, or actually we see the triangle right here. Triangle LMN is similar. That's what that little sign right there means. To triangle RST. So that means L is comparing to R, M to S, N to T. So LMN RST. So when you read it that way, we have L to M is going to be congruent to R to S. Like so. And I should have a line over the top of this. I don't know how I can easily do it in this, let's see here. There we go. There's my line across the top. Now, line MN, or segment MN, or side MN, is similar to, what is it going to be, ST. And there should be a line across the top there. I'm not going to spend time doing that every single time. And then NL is TR. And line there, and line there. I decided to do it. All right. Angle L is congruent to, which one is it going to be? Well, it's comparing to R. So this would be R right here. And then angle M is comparing to S. And finally, we have angle T. And there should be like a little boom. And then another one from there to there to create a little angle sign. Boom, boom, boom. Run out of space. There you go. Looks a little weird, but whatever. That's right. Okay. Write a proportionality statement. Okay. So this is where you want to actually compare each side over the other one. So we know LM, RS are together. So you can write, I'm going to do underline LM, RS. So not underline those ones. Where's my underline tool? There you go. RS. And this is equal to, so the LM, then we have MN over ST. And then put a little equal sign somewhere, right there. And finally, our last comparison or proportionality is NL over TR. All right, and we can make this look a little better if we want to. All right, that's the proportionality statement. I just wrote it down here instead of up there. So that means that all these sides are equal to each other, or these fractions for proportionality. So if you do LM over RS, LM is 9, RS is 6. So it'd be 9 over 6 is equal to MN over ST. So 12 over 8. Is 9 over 6 equal to 12 over 8? If you simplify them, they are both equal to 3 over 2. So this triangle is 1.5 times bigger than that triangle. And if you look at the numbers, that's true. 15 over 10 is also equal to those numbers. So here's a U try. So you want to go through and read it. A, B, C, D is similar to H, G, F, E. So A, B, C, D. And then we would have H, G, F, E. So A, B is similar to H, G. B, C is similar to G, F. C, D is similar to F, E. And finally, D to A is similar to E to H, like so. FE. Oh, I guess I want you to drag these down. I'm kind of confused on what that's there for. And then angle A is similar to angle H. And then angle B is similar to angle G. Angle C is similar to angle F. Sorry, that's G. And finally, angle D is similar to angle E, like so. And the proportionality statement would be having AB over HG is equal to BC over GF, CD over FE, and finally equal to DA over EH. And you do. We will allow you to do this one on your own. Okay. Similar to the last two questions.